Hi students, and welcome to our next video titled Factoring the Difference of Two Perfect Squares. Believe it or not, the trend continues. We can factor what we call the difference of two perfect squares by, ta-da, grouping. So check out example 1. It says factor x squared minus 9. Now, first let's talk about the reason this is a difference of two perfect squares. So difference obviously means subtraction. So there's your difference of two. Here they are, 1, 2. Perfect squares. Okay, so x squared is considered a perfect square because it can be written as x times x. And 9 is a perfect square because 9 is 3 times 3. So by definition, a perfect square is a number where you can write that number as the product of two similar numbers, 3 times 3, x times x. Okay, so to factor the difference of two perfect squares by grouping, we do the same thing we've been doing here. So you take the coefficient of the squared term, which is a 1, and you multiply it by the c, negative 9. Now, the thing about difference of perfect squares is this. Some people like to think of it as this. They say, well, where's the middle? Well, there's the middle. There is no middle. See, we've been factoring trinomials. In difference of perfect squares, the middle is gone. So if you'd like to put a placeholder in there, you can. It's really x squared plus 0 x's minus 9. So we're still multiplying the 1 on the x squared times the negative 9. So 1 times negative 9 is negative 9. And the middle slides down as 0. So I'm looking for two numbers whose product is negative 9, but whose sum is 0. And there's only one answer that's going to make that happen. And that would be negative 3 and 3. Negative 3 and 3. Negative 3x plus 3x is going to make that 0x. And negative 3 times 3 is going to make that negative 9. So we are going to replace this 0x by writing it like so. So it's going to look like this. X squared minus 3x plus 3x minus 9. See? Exact same. Now I will group. So I'll group together the x squared minus 3x, and I'll group together the 3x minus 9. Notice one little thing. In our former videos, or if you were in class, what I like to do here to make life simpler in grouping, if one of my factors is positive and one is negative, I like to put the negative first, because what that does is it leaves me with a positive in between my second and third terms, and then I don't have to worry about switching my signs back here. So just a little food for thought. Okay, so now I factor out my GCF. So GCF here is going to be an x, and I'm left with x minus 3. Here my GCF is a 3. And I'm also left with x minus 3. And so my final answer, common, x minus 3 comes. Leftovers, x plus 3. Ta-da! There's my answer. Now, of course, I can check it always by multiplying back these two factors, see if I get back to my original problem. So let's do that. X times x, x squared, x times 3, positive 3x, negative 3 times x, negative 3x, negative 3 times 3, negative 9. And so these two will cancel out right here. And so I'm just left with x squared minus 9. That's a great check because it gets me right back to the purple. Factoring the difference of two perfect squares, it's still just grouping. Okay, let's go to the next one. Factor 9x squared minus 100. the difference of two perfect squares. See, this is 3x times 3x. This is 10 times 10. Difference of two perfect squares. Okay, let's rewrite it with the 0 term in the center. So let's rewrite this as 9x squared plus 0x minus 100. Okay, now we'll multiply 9 times negative 100. 9 times negative 100 is negative 900. And I'll slide the 0 underneath. So I'm in search of two numbers whose product is negative 900, but whose sum is 0. So right off the bat, I don't know why it just came right to me. I'm thinking 30 and 30. It's not going to be 100 times 9 because 100 and 9 don't cancel out to 0, but 30 and 30 do. So if I take, and remember, I'm going to put my negative first. So negative 30 times positive 30 is negative 900, and negative 30 plus 30 is 0. Excellent. And I can put those x's with it, like so. All right, so let's do a rewrite. We're going to bring down 9x squared minus 30x plus 30x minus 100. And you're right back where you started. See, this is the purple because these would drop out. Now we go to group. So we'll group together 9x squared minus 30x and 30x minus 100. GCF up front is going to be 3x. It's going to leave me with 3x minus 10. Here, looks like it's going to be 10 as my GCF. 10 is the biggest number that goes into both 30 and 100, and it'll leave me with 3x minus 10. And so you see the commonality here, 3x minus 10, 3x minus 10, and what's left over is this 3x and the plus 10. And that's my answer to this problem. And if you check it, again, I won't lengthen the video with the check, but you can certainly check it by multiplying 1, 2, 3, 4, and you're going to get right back where you started. Okay? Excellent. And the last one. Factor 25a squared minus 64b squared. Okay, so let's rewrite it first with our 0 in the middle. Now we're going to have to pay attention to something here. So when we write 25a squared, when we go to write the 0, in every other example so far, we just had an x in the front, so we made this 0x. Now that we have an a and a b, this is going to be 0ab. I'm going to write them both with the 0, and I'll show you a little bit more of why that is later. Minus 64b squared. Okay, so 25a squared plus no ab's minus 64b squared. Okay, so now we're going to take 25 front times negative 64. If you take 25 times negative 64, and you can do that, I actually did it by hand earlier, but I'll show you here, 25 times negative 64, you get negative 1,600. So that's going to come here. So we're looking for two numbers or terms that multiply together to give us this, but add to give us 0ab. So this is going to have an AB on it, and this is going to have an AB on it. But what are the two numbers? Well, I played around with it, and I think it's going to be 40 and negative 40, which is the square root of 1,600. If you take the square root of 1,600, look what you get, 40. Okay, difference of perfect squares. Even back here, you know, with the 900, I just knew that 30 times 30 made 900, but if you take the square root of 900, guess what you get? 30. So, and even look at this one. What's the square root of 9? 3. So I know that two numbers that multiply to give me negative 1600 will be negative 40 and 40. And the reason I love the square root idea is because when you take a square root, you're getting a number times itself, right? A number times its very own self is going to make this 1600. Well, guess what? A number plus its very own self, opposite signs, always makes 0. So you see a pattern here emerging. So what I'm going to do next is write this out, the original problem. I'm going to write this as 25a squared minus 40ab plus 40ab, and then the back, minus 64b squared. Group them together, 1, 2. Okay, GCF. Well, this is more of an interesting GCF here. All right, the biggest number that goes into 25 and 40 would have to be 5. And the fewest exponents, well, if you compare these two A's, the fewest would be just 1A. And if I compare B's, the fewest would be none, because this term has no B's. So I'm going to go with a GCF of 5A. When I take 25a squared divided by 5a, I get 5a minus 40ab divided by 5a is just going to give me 8b plus. Okay, the biggest number that divides into 40 and 64 is going to be 8. And my fewest exponents, well, the fewest a's is none, and the fewest b's is 1. So 8b. 40ab divided by 8b is going to be 5a minus 64b squared divided by 8b is 8b. So now when I look this over, I have a 5a minus 8b with a 5a minus 8b. So I'm going to write that down, 5a minus 8b, and the rest of it, 5a plus 8b. Okay, now this is going to show you, actually checking this problem is going to verify why I needed to put AB with my 0 here. The truth of the matter is, the only way you're going to get back to a 25a squared when you're checking is if you have a times a. So 5a times 5a is indeed 25a squared. And the only way you're going to get a negative 64b squared on the back is if both of these have a b with them. So negative 8b times positive 8b is going to end up eventually with the negative 64b squared. So there is your problem. So what happens is, if the fronts have to have an a and the backs have to have a b, then inevitably when you take the 5a times the 8b, see, you're going to get plus 40ab there. And then when you do this guy to this guy, you're going to get the negative 40ab, which I'm going to have to caret and put up here, negative 40ab, because I ran out of space. And then the 40ab and the negative 40ab are what cancel to the 0ab. So that's why when you have one variable here and a different variable on the back, your center, when you multiply, is going to have them both. So that's why I did that. So that makes this problem just a little bit more challenging. All right, difference of squares. One other thing, guys, before we leave this video, see, back in the day, back long ago, I did not teach difference of squares by grouping. I actually taught difference of squares by more of, let's call it a trick, okay? Look at, for example, look at this problem, x squared minus 9, right? Well, you knew the x squared was x times x, and you knew the 9 was 3 times 3. Look at that, and then look at my final answer. X minus 3, X plus 3. X minus 3, X plus 3. Okay? 3 being the square root of 9. Look at the next one. 9x squared minus 100. We know the 9x squared is 3x times 3x, and 100 is 10 times 10. So maybe we do 3x minus 10, 3x plus 10. 3x minus 10, 3x plus 10. It's like we're taking the square root of 9 and the square root of 100 and doing 1 minus and 1 plus. This is like a trick. It's a pattern. But I don't really recommend it because we've been factoring by grouping. If you just group every time you factor, you're not going to go wrong, and you're not going to have to memorize any tricks. Even this last one, though, it will work, because check it out. 25a squared would be 5a, 5a. 64b squared would be 8b, 8b, if you square root these. 5a minus 8b, 5a plus 8b. See it? Okay. I just mentioned it briefly in case you were noticing a pattern. Okay, thanks for watching.